Hot water heater set at 120. I've been running it for a few minutes so it warms up, heats up. $119, $121, $121, $119. So my water heater is pretty accurate. We'll call it 120. There's 120. Cold water starting temperature 71, 71. Approximately 70 to 71 degrees. We'll call it 71. With some variation. We'll call it 72. The laser is going through the cup. Maybe I should do it in a white cup. We'll call it 72. Okay, after 5 minutes, still liquid. Closing back up quickly. Didn't think there was going to be much difference after 5. 20 minutes in. Still both very liquid. 25 minutes. Still both liquid. Okay, 30 minutes in. Still both liquid. Hot side is at 55 degrees. Sorry, 47. 55. Cold side is at 35. I think we're going to bust a myth today that hot water freezes faster. The cold water is already at 35 degrees, which is only a couple of degrees above freezing. And the hot side is a good 20 degrees warmer still. Okay, 35 minutes in. Oh, we got some freezing going on in the cold side and no freezing on the hot side. Looks like the myth is going to be busted here. Okay, 31.5 for the cold side and 44 on the hot side. 46, 47. We'll call it 45. And 33 on the cold side. Cold side is definitely winning. I can see crystals. Myth is gonna be busted. 40 minutes in and noticeable freezing crystals in the cold side. And the hot side is still very, very liquid with no noticeable crystals at all. Cold side registers 32.9, which is within margin of error. 32 is freezing. And we're still at 41 degrees on the hot side. 44, 45, 47, 46, 43. There's some variation there, but obviously it's around 45 to 46 degrees. And the cold side is just about freezing temperature. Well, it is freezing temperature because it's freezing. And the hot side, not so much. Same exact tap water. This one started at 120 degrees, and this one started at 71 degrees. 71 to 72, 119 to 120. Okay, so anybody saying that hot water freezes faster, they're full of bullshit. Don't believe them. It's bullshit, myths, and lies, because they haven't fucking tested it. Okay, you guys, 45 minutes in, and still cold side is beating hot side by a far margin. In fact, there's noticeably more crystals in the cold side and 0 still in the hot side. Hot side registers at 45 degrees. Cold side is registering a little above freezing at 35. Just slightly above freezing at 33.6. Hot side 44. Cold side 33. Hot side around 43 to 44. It's still about a 10-degree difference. Use the same water source, my tap, one at 120 and one starting at 120 and one starting at about 71 degrees. It's a myth, people. Don't believe the lies. Hot water does not freeze faster than cold water. If you want me to repeat the experiment again using boiling water, I will, for all you idiots out there that want me to. Okay, guys, 50 minutes in. Even more ice crystals there. And 0 in the hot side still. $40 degrees on the hot side. $34 degrees on the cold side. 41 on the hot side. 34 degrees on the cold side. All right. Okay, you guys, 55 minutes in. Still about the same amount of crystals on the cold side, maybe a little more solidified. And 0 crystals on the hot side still. 0. 0. And the hot side is registering at 42 and 33, 34 on the cold side. 41, 41, 41, 34, 35, 33, 34. All right. Well, cold side is holding pretty steady as it phase transitions. Not quite 32. And the warm side is still slowly dropping in temperature. One hour later. Okay, so after 60 minutes, appreciable freezing in the cold side, and still no freezing going on in the hot side after an hour. Hot side is 39 degrees. 39 degrees. 39 degrees. Cold side is 34 degrees. 34.5 degrees. 34 degrees. All right. This myth is looking very, very busted. I don't know who these supposed scientists were that tested this theory that hot water freezes quicker than cold water, but they're fucking stupid. chances are they probably got their samples mixed up and we're not tracking the temperature along the way. And they were just like, oh, this is the hot side and it froze quicker, even though it wasn't actually the hot side. That's my educated guess on that, folks. Don't believe everything you see and hear on the internet misinformation web. Okay, guys, an hour and 5 minutes in. Still about the same amount of ice crystals in the cold side and 0 ice crystals on the hot side. Let's see if the temperature differential is getting closer. 36, 37, 36. So yeah, the temperature is still dropping on the hot side. And 32 on the cold, 33 on the cold, 33 on the cold, 33 on the cold, 37 on the hot, 37 on the hot, and yeah, no visible difference in the volume, and the cold side is definitely freezing, and the hot side is definitely not freezing yet. Not until it gets to about 33 degrees will it start to form ice crystals, when it starts to do the phase transition. Okay, so, you guys, there is no Mpemba effect. The supposed scientists that demonstrated the Mpemba effect are dumb fucks. Okay? No Mpemba effect. There is no such thing. Okay, y'all. Hour and 10 minutes in. Still no ice crystals on the warm side. But its temperature is 36, 35, 35, 36. We'll call it 36. Cold side is still holding at 33. Dropped a little bit. 33. It's probably right at 32. This thermometer's probably a little bit off. Hot side is at 35. So the hot side is almost down to freezing. Once it gets down to 33, you'll start to see ice crystals in it as well. It's actually 32. Like I said, my thermometer is probably off by a degree. So once it hits 32, you'll start to see the ice crystals. All right, so another 10 minutes and we might see some ice crystals forming in the hot side. And then it'll hold the 32 degrees until the entire thing of water is frozen. And only until the entire thing is frozen, it'll hold at 32 degrees. That's the freezing point of water. And once the entire thing of water is frozen, then it will continue to drop even further. And let's see, my what are those 2 degree hash tags, 2 hash marks, 22. Yeah, they're 2. So my freezer is at 30 degrees. Well, it's been open for a while, so this is going up now. Okay, everybody, it's been an hour and 15 minutes, approximately. Maybe a little bit longer, but there's still no ice crystals on the warm side, hot side. It's now getting down to cold. It's at 34 degrees. 34 degrees, 36, 34, about 34 or 35. Cold side is still holding at 33 degrees, and like I said, this thermometer is probably off by a degree. It's probably hot by 1 degree. So cold side is still holding at 32 degrees as it freezes. And there's definitely more and more ice crystals as the time goes by slowly. Well, as time goes by. We can talk about relativistic time later, but for all intents and purposes, time is the same for both of these. And still no ice crystals on the hot side. Started at 120 degrees, 119. And this started at 71 degrees, and which is probably like 70 degrees, and 119, which means it started at like 118 degrees maybe. So, yep. The whatever Mpemba effect, it's busted. It's totally busted. I'm just waiting till we see some ice crystals in the hot side. Now, let's see. I should have checked it right when I opened it. This thermometer keeps going up when I open my freezer. I'm going to stick it further in to my freezer. Okay, closing it back up. Okay, it's been an hour and 20 minutes. Still more ice crystals forming in the cold side. And any yet on the hot side? Nope, not yet. Its temperature is 35, 34, 34, so it still needs to cool down about a degree. Here we're having 32, 33, 33, 34, so it still needs to cool down by about a degree. And let's check my thermometer. My thermometer says the air temperature is 20 degrees. And let's check this frozen meat. 6 degrees. 4.5 degrees. 2 degrees. 4 degrees. 2 degrees. 3 degrees. 2 degrees. -2. That's pretty cold. 7, 6, 7, 7, 7.5 on the fish. Huh, that's interesting. It's getting -3 on the ground bison. I think the fish is more accurate. 6, 7, -4, 2, 8, 5, 6. I think the fish is more accurate. Maybe the white color. Huh, interesting. So it's saying between 2 and 7 degrees. So it's pretty damn cold. Once something freezes, it gets pretty damn cold in this freezer. And we'll close that back up. Okay, it's been an hour and 25 minutes. Still no ice crystals? Oh my goodness. 37, 36, 36, 36, 33, 36. I think I had the door open too long last time. me shut it again real quick. Okay, it's been an hour and a half. Any crystals yet? Nope. It is 34, 34, 34.3, 32 and a half, 35, 32 and a half over here, and 34 over here. Okay, still no ice crystals and no hot side. Okay, it's been an hour and 35 minutes. Oh, and we finally see some ice crystals. Yay! Finally! And compared to over here, tons. Almost solidified. Over here, just barely some ice crystals. And the temperature is 34, 35, 35, 33, that's probably more accurate, 33, 33, and over here on the cold side, 33, 33, 34, 32. So there's some variation with my thermometer. 32, 33, 33. So 33, 32. They're about both freezing temperature now of ice. And that, like I said, they will hold that freezing temperature until the entire thing is solidified, but you can see those ice crystals starting to form there. Yeah, I see them. Focus. Yep, see them. Very cool. Okay, myth is busted. There's no stupid Mpemba effect, guys. Zero. And let's take a look at how cold some ice cubes are of ice that's already frozen. 27. Let's open it up. The plastic is getting in the way. Pardon the shakiness while I use two hands. And that says 26 degrees. 32 exactly. 32. Huh, 32. So the ice in the door pocket is holding at 32. There it says 30. 31.8. So there's some variation. So it's about holding at freezing. I wonder if the fish still says 9, between 7 and 9. I wonder if I put these ice cubes further back in my freezer, if they'll get colder. They've been sitting in this door pocket that I've continuously been opening, so I don't know if that contributed to them being 32 versus a little bit colder. I'm not sure, but ice can be colder than 32 degrees. I know that for sure. Okay, you guys, and just having the door open of this few minutes, the ice crystals went away. So there is some effect of me opening the door every 5 minutes. In counting the time, I did not count the time that the door was opened. Every time I closed the door, I set the timer for 5 minutes. So the total amount of freezing time was when the door was closed. And I did have the door open. I tried to minimize it, but I did have the door open for a few minutes during some of the filming. So that definitely contributed to the temperature not dropping as quickly as if I had just left the door closed the entire experiment. Okay, that's it, you guys. So the time it takes for the entire thing of water to freeze should be the same for each the hot and the cold side. Once they get to 32 degrees, the time it takes for the entire amount of water to fully solidify and crystallize should be the same if you start timing from when the first time you see ice crystals form to the time the entire thing is frozen solid, because it's the same volume. So it should take this the same amount of cooling to solidify the same mass of water inside the containers that I have, which are the same volume and the same shape. That's it, you guys. Mpemba effect does not exist. Hot water takes a hell of a lot longer to start to freeze to begin with, and then adding that the time it takes to solidify. So it's totally busted. Cold water freezes a hell of a lot faster than hot water. It's going to be the same for boiling water. The thing about other people's experiments is they probably had too many confounding variables, and I'm willing to bet that the guy Mpemba, who the effect is named after, probably pulled a fast one on his teacher and switched the ice cream vessel, is what I'm thinking. Also, cream and sugar is not water, right? So they're gonna freeze at different rates depending on how much sugar and how much cream and all those variables. And there's no direct correlation or translation to the freezing time it takes for water to freeze. Just from a thermodynamic perspective, I knew that the hot water would take a lot longer to freeze because it thermally has more energy to begin with, the hot water does, than the cold water. Temperature is just the measurement of the kinetic motion of the molecules in whatever you're measuring. So the faster the molecules are moving in the material, then the hotter the material. And so the kinetic motion of the water molecules at the 120 degrees, the water molecules are vibrating and moving a lot faster in 120 degree water than they are in 70 degree water. And so for them to donate that energy to the air in the freezer, it's going to take a lot longer than water that has less thermal energy. That's just thermodynamics and chemistry 101 right there, and physics. So yeah, it's totally busted, completely erroneous to say that hot water freezes faster than cold water. And whoever does, they're lying and they're spreading misinformation on the internet, and they're unwilling to test it for themselves. I knew the answer going into this experiment, but I just had to do this experiment to show people that there's so much misinformation out there on the internet. One person gets it wrong and they spread the lie, and the lie just continues and continues and continues. Sounds familiar, right? Lies spread that continue. That's all I have to say about that.